Okay, so we're going to take this arithmetic sequences to another step, where now we're going to be asked to find the nth term of a sequence. And so we have this situation here where it says consider the arithmetic sequence, and we have an arithmetic sequence here of 3, -10, -23, and -36, and it goes on out to infinity, I suppose. This sequence does. We're told it's an arithmetic sequence. And in order to find the nth term, we can use this formula right here, where, let's say that, hopefully I can write it right here, that an equals some number in the sequence. Let's say a number in the sequence, where A stands for arithmetic sequence. A number in the sequence. And A1 is the first number of the sequence. So first number of the sequence. I'm going to abbreviate this with a pound sign. First number of a sequence. And n, of course, is just going to be a number. And let's see, our other variable here is d, which is the common difference. And we can take that formula, from here we can develop a formula that will allow us, I'm out of room, will allow us to determine the nth number of the sequence. So first let's go in here and let's say, okay, well, what's our common difference? So I've got 3 and -10, and if I'm looking for the common difference between 3 and -10, so I'm 3, that's +3. My next number in the sequence is -10, so I'm moving to the left, and my common difference is -13. And I'm just going to verify that holds true throughout. So if I go from -10 to -23, well, that's another -13. And from 23 to 36 is a third, -13. So I'm satisfied that my common difference is, in fact, -13. So now I'm going to go in here and work on this formula. So we're going to say here, let's put this maybe in a different color. So we've got an is equal to, well, a1, I'm going to substitute in the first number of the sequence here, 3, plus n, which I'm going to leave as a variable, minus 1 times -13. So I want to distribute this -13 first, and so then we've got an equals 3. I got -13 times n. That's going to be -13n. And then -13 times -1 is going to give me a +13. And let's go ahead and combine the like terms here, and we can finish off our formula anyway, where an, any number of this sequence, is going to be equal to -13n, a variable, plus 16. All right, so we've developed our formula. An equals -13n plus 16. Let's continue on. Okay, so we're moving to the next step, where we're now being asked to find the 15th number of a sequence. And so let's use the formula that we developed in the previous slide and see if we can't determine that. So then I'm going to substitute in for n now, 15. So I'm trying to find the 15th number of the sequence, and that's going to be equal to -13 times 15. Again, the number of the sequence, I'm looking for the 15th number of the sequence, plus 16. Okay, so I think I'm going to jump over here to my calculator and do a little calculating. And let's see, when I take -13 times 15, so this 15th number of the sequence, -13 times 15 is -195, plus 16, So let's go ahead and combine those like terms. And when I take negative 195 and add to that 16, I'm going to discover that my 15th number of the sequence, I didn't want to do that. Let's erase that, erase that, erase that. Put 15 down here, is equal to negative 179. All right, how about that? All right, so we've been asked to do a couple of other operations on this. One, we've been asked to graph the first 5 terms of the sequence, which we were given 4 of those. And obviously, the 5th term we could just apply the common difference that we're working with here as negative 13. But we're going to graph this on the graphing calculator. Now, if you wanted to get out a piece of graph paper and plot the 5 points and connect the dots with a line, you could do that. But if you remember, we discovered that we had an equation that we could actually treat as a function. We had a to the n equals negative 13n plus 16. So I'm going to see, okay, I've got my window settings up here. That looks okay. I'm going to go into y equals, and I'm going to put in negative 13, and rather than doing n, I'm going to use x. Negative 13x plus 16, because I determined that this is an equation that will allow me to find any term in the sequence. And let's see what this looks like on the graph. Okay, so I got a negative sloping graph. It's pretty steep. Well, that makes sense because I've got negative 13 as my lead coefficient in that. And then lastly, it says that which term is of the sequence is negative 114. And I'm going to go in here to my table. I believe I've got enough room to see this. Okay, so what I've got here is I've got a table of x values, but we're going to start down here. So when x is 1, my first number of the sequence is 3. And we recall that our sequence was 3, negative 10, negative 23, negative 36. And so when x is 1, that first number of the sequence, the number is 3. The second number of the sequence is negative 10. Third number of the sequence is negative 23. Fourth number of the sequence is negative 36. Those were all things that we were given. And we're looking now for which number, which term of the sequence equals negative 14. So I'm looking for a y value, a y1 value, where it is negative 114. So let's scroll down just a little bit more. And right there. So negative 114, when x is 10, or I could say that when the 10th number of the sequence, that's going to equal negative 114. But we've actually put this in a function and have graphed it. Or if I plugged in, it could be the same thing, if I plugged in 10 for n into that formula, negative 13 times 10, that would be negative 130 plus 16. Well, that would also give me negative 114. Okay, cool.